Good afternoon. This presentation is about a multidisciplinary research project that uses information technology to help to solve one of the most important problems in Costa Rica is the infrastructure. The motivation on this project is that road infrastructure is the major weakness of the Costa Rican economy. In particular, a significant percentage of the national bridges show an average or critical condition. We will show in this presentation. The problem, what is the problem with this project? The general condition of the road infrastructure is a national socioeconomic weakness. This is very, very important. A significant percentage of bridges show a regular or critical condition. Lack of technical information is another problem about bridges. In this moment, we are working in prepare the national inventory. Costa Rica didn't have a national inventory of the bridges. This is an important. We have limited resources for infrastructure, planning and maintenance. Weather and geological conditions have a huge impact on bridges. The prioritization of projects in road infrastructure is essential, and we work about that. Why the bridges? Why is important the bridges for Costa Rica? Because the bridges control the system capacity. The capacity of the road is controlled by the bridges. For example, in one road, you can pass a truck about 40 tonnelages. The control is the bridges, not the road. It's the higher cost per kilometer. It's about 40%, 400% more the cost of the bridges than the asphalt, for example. If the bridge falls, the system falls. We can use a road if the bridges fall. This is an example of the situation. This is the bridges that the Costa Rica Institute of Technology inspected between 214 and 215. Is the principal roads. We expect in the national roads about 104,000 bridges, and in the municipality, 600 bridges. And in this part, we're not working in this part. We are only focusing the national roads, but the problem is bigger with the municipality bridges. This is the example of the information that we create about every bridge in this country. This is an example of the condition of the bridges. For example, this is the John expansion. The red color is the poor condition. The yellow color is a fair condition, and green is a good condition. We show here that the condition of the bridges in Costa Rica is a problem because the majority of the bridges have problems that deficient of the structural behavior. This is the security, for example. This is the superstructure, and this is the substructure. This is the foundation of the bridges. The hybrids 3.0 is, we have a main question. It proposed the design of a prototype monitoring system bridges, which allow to integrate information for existing structure. Their characterization is potential risk and monitoring for better decision making. This is the problem in Costa Rica, the decisions about the infrastructure. This project is part to the e-science program. We bring together with different schools. I am of construction engineering school, but we work with other professors like industrial production engineering, material science, electronic engineering, forest engineering, and computer science. It's a multidisciplinary. This is part of the big project. We worked in the IBRIS 1, IBRIS 2, and now in IBRIS 3. In the first part of the project, we building capacity. It was an initial project. We developed basic structural health monitoring capacity. In the second part, we work in the integration of information, and now we are working in the bridge monitoring system. And in the future, we hope to have a e-bridge tech company that offers services in the structural health monitoring, not only in Costa Rica, even in Central America and maybe in Latin America. In the bridge monitoring system, we have to ask some questions. How safe is the bridge? Compare the real and theoretical model analysis. How can access information for different points? We have to solve different strategic queries. What is the structure of the bridge? Is an arc, is a trusses? What kind of joints have the bridge, for example? How do the bridge structures perform? How is the displacement, the deflection? What is the vibration in the bridge? How geographic aspect impact the bridge? For example, the river, basin, roads, and other factors, socioeconomic, for example. And we integrate all this information for make some reporting to the government take or make decisions better. We hope that. This is an example. For example, if this is a real bridge, this is a theoretical model. They are the plans of this, the blueprints of this bridge. This is a kind of non-destructive testing that we use. This is magnetic particles. This is to find some cracks in the structure, in the beam. This is the difference information that we have with the sensors, the displacement, for example, displacement in the joints, the vibration of the structures. And this is an example of the reliability model. The green is the capacity of the bridge, and the orange is the characteristic of the transit, and we use this kind of information to find the possibility of the bridge have a collapse soon, or what is the probability of the bridge fall in the future. This is a resume of the model. We detect different damage in the bridges, detect, localize, typicate the kind of damage, and we have the calculated extension of this damage. Now we are working in the structural health monitoring, but in the future we are introduce environmental conditions and the transit. We use different inspection methodologies, visual, virtual, and diagnostic. And another, this is very important for us, is the electronic monitoring, permanent monitoring, or the fin time monitoring in the bridge. All information is to decisions-making process. The evaluation of process is, we have a goal is to have 100% of the inventory, and the visual damage in the bridges. And depend of the different criteria, we have to choose that the bridge need a diagnostic, a load rating, calculate the vulnerability, the reliability, and the use life of this kind of bridges. In this project, we use, this is the part, the most important part, we use the business intelligence models and tools, bridge monitoring system project aimed at the design and development of a system prototype to support the integration of different information about the national bridges structure regarding technical specification, structural reliability, performance variables, as well as geographical and environmental aspects. One of the novel aspects of the eBridge 3.0 is the application of business intelligence model and tools that use, in other case, to generate control panels or strategic key performance indicators of bridges in the country. Such monitoring system will be useful to support strategic maintenance, planning, and optimization of resources investment for relative government institutions, like Ministry of Transportation of different municipalities. This is a model. We have a database. We prepare different data cubes with, for example, multidimensional data structure for rapid analysis. Data points can be manipulated to different questions. Dimensions could be the bridges, the regions, what is the province, for example, the evaluation, the qualification of the bridge, the roads, what is the principal roads or it's not a principal roads, measures among the bridges, average of the evaluation of the different variables. And now we are exploring the application of the business intelligence techniques in eBridge using Pentaho. Pentaho is a free software that we use in this moment to create these cubes and different indicators. This is, for example, this is a Pentaho. The data cube analysis provides different answers to relevant questions. This is an example of question, average of the bridges, amount of the bridges per route, per province. We can use to evaluate what is the risk of this route or different information. We have there are the dimensions, the measure, and we drag and drop for different questions and have the information. To show the information, you can show by the table, or there are another possibilities, like a map, for example. The different colors represent how many bridges are in this province, or what is the condition. We can represent in different forms. This is the type of the bridges. This is a traditional graphic. This is another type of graphics. This is an examples that represent the information of these indicators. Conclusion and future works. The ongoing eBridge project approach will allow a flexible execution of the strategic queries about the real structure condition of bridges in Costa Rica. In this moment, we don't have this information. Through the application of business intelligence techniques, such as key performance indicator panels associated to specific structural and environmental variables, these indicators and monitoring panels will have a positive impact of the efficiency of the resource investment and planning of the national public infrastructure. It could be important for Costa Rica. The preliminary results will be extended to include around 400 bridges, and more data cubes and visualization features will be made available through a web interface. It could be in the near future. This could be very important for the ministry, for example, of the different people in the CONAVI or MOP. There are institutions that taking or making decisions about infrastructure in Costa Rica.